Good morning. Uh, Cheers. It's my Tim Hortons coffee, like a good Canadian does every morning. Actually, that's not true. I think I sometimes drink McDonald's or I brew my own. And this one's actually from yesterday. I just reheated it. So I've been thinking about math ideas, which are really critical, but can be kind of explained in under 5 minutes. And actually, this particular idea, I did talk about it and write about it in Chasing Rabbits, my book, which is coming out this fall. And if you look at this question, first of all, like where would you imagine seeing this question? Uh, I think for most of us, we'd probably think it's going to sit in a high school classroom, maybe even maybe a contest setting for the best math students, um, especially after they've learned maybe the exponent laws. I'll be blunt. What a waste. It's great. It sits there. But really, if you really want to get the most bang for your buck, where it should lie is where it sort of intersects, that sort of burgeoning mathematical or just general curiosity of kids with their sort of just out of reach, sort of, you know, academic maturity with mathematics. So I think this sits actually in elementary school so that you can teach things about exponents and their laws. So this is how I think it would go. And this is I've done this before, so this is the kind of reaction that's come about. So which one's bigger, right? You just put these two numbers on the board in a, maybe a fourth grade class, and first of all, kids probably don't even know what those numbers mean. But there's a little bit of curiosity happening here now, right? Okay, it's one or the other. One's bigger, but I don't know which. I don't know what they mean. So, why not just sort of, you know, start explaining what it means? So you start to write down, I don't know, maybe like, make sure my pen is ready. Come on, get your pen ready, right? So it's 2 times 2 times 2 times 2 times 2. And at this point, you might ask the kids, how many twos do you think I'm going to write? Pretty sure some of them might actually say 3,000. So sure enough, you've got 3,000 of those twos all multiplied. And they already know what's going to happen here is you're going to have 3 times 3 times 3. Give me some room for some ellipses. And you got 2,000 of them. And ask the question again. So now they know what that question means in terms of its value. It's still out of the realm of like just any sort of calculation they can do in their head, but they now have a toehold. Now they can kind of use their gut instinct a little bit better, which is fine. And maybe you're going to get, hopefully, a split response between the two. But you want to ask the kids, there's a definitive way to know which one's bigger. There is a way. And we don't even have to multiply it all out. So you got their curiosity to peak. So maybe you should start with a simpler problem. And just for an understanding of maybe how exponents work. So let me just go to this side here. And I'll write down. And again, you've already started unpacking the idea of multiplication to exponentiation. So here, maybe there's kids in the class who are good at doubling. And that's 64. And all you're doing is just sort of showing how these numbers, and the kids love to see a new way to maybe a more compact way or learn something new. Like now they're going 3 with a small 4 raised in the sort of right superscript. That's not 3 times 4. Oh, that's 3 times 3 times 3 times 3. There's 4 threes written with 3 multiplication signs in between. And you can help them out here a bit. 3 times 3 would be 9. 9 times 3, 27, and 81. So the reason why I did that is because now I'm going to start hinting towards maybe how we should look at our original question. So you tell kids, hey, 6, two numbers multiplied to 6 are 2 times 3. That question still stays the same. And similarly here, right? 2 times 2 is 4. And whatever we do in terms of now, we're going to be doing very indirectly exponent laws to verify that when we do write it a different way with where their exponents are, we're still going to get the same answer. So you focus on these two, and we know that it could have been switched, especially the first case, 3 times 2. We're still going to get 8 squared, which is 64. But just for the time being, do it like this. Well, this 2 times raised to exponent 2 is 4. That gives you 3. 3 raised to exponent 2. Hopefully kids know that's not 3 times 2. That's 3 times 3, which is 9. And we're left with the 3 and the 2 still there. And that gives you 4 times 4 times 4. And that gives you 9 times 9. And lo and behold, you still get the exact same answers. So I started from a question which obviously they could not do. But there was an element of I'd like to know which one is bigger, and we're getting there. So you can see what's going to happen now as I've wonderfully run out of room. So I'm going to try to give myself some room just in here, make some sort of right-leaning mountain. So now we have this situation, and we've got this situation. Hey, this is like a pop-up video. There was no planning involved. There was a cup of stale coffee from yesterday, so I will do a better job next time. This is fun too. So look what happens now. You have 2 to the exponent 3, which is 2 times 2 times 2, which is 8. And this is 3 to the exponent 2, which is 3 times 3, which is 9. Oh, now the comparison of which one is bigger is a lot easier. Because their exponents are the same number of times we're going to write out that number, but which is the bigger number, 8 or 9? And it's 9. So now I don't know if I did this consciously or not, but I didn't use very like specific high school language like with base or the multiplication power law. I just wanted to use sort of what was understanding of kids you would see maybe, again in a fourth or fifth grade class, seeing this question, using a question which sometimes sits in a contest question in high school, bring it down to elementary and let the natural curiosity. Kids are doing adding and multiplying by this stage, so they're probably thirsty for exponentiation. And there's actually more after that. But that was my quick sort of, math snack, math bites of using uncertainty to teach exponents.